Introducing the Snap-on Counselor 2 Power Balance Probe, a new dimension in automotive technology that enhances the dynamic testing capability of the Snap-on Counselor 2 digital oscilloscope. The Power Balance Probe relays instantaneous engine speed changes that occur as each cylinder fires. A power balance test can be performed on any type of engine, including diesel engines, but it's specifically designed to measure cylinder contribution in engines where shorting is difficult, if not impossible, to do. Since the probe wheel monitors engine speed from a moving crankshaft drive belt, there's no need to disconnect or bypass control systems. Use the power balance test on engines with distributorless ignition or with computer controls that automatically compensate for RPM loss. In this video, you'll learn how to set up the Snap-on Counselor 2 digital oscilloscope to display the cylinder power balance waveform, how to connect and use the Snap-on MT3000 420 power balance probe, how to relate waveform characteristics to specific engine activity, and how to identify the causes of engine performance problems from abnormal test patterns. You'll find complete instructions for using the Counselor 2 digital oscilloscope in the Counselor 2 User's Manual. The special section on the MT3000 420 Power Balance Probe provides detailed instructions for using the probe and interpreting the test results. To set up the Counselor 2 for a cylinder power balance test, you should follow the standard procedure for conducting any diagnostic test. On the Snap-on screen, enter appropriate engine information for the vehicle you're going to test. Be sure it's correct. Select Cylinder Test Menu. Then, go into the Power Balance Waveform test screen. Engine RPM is displayed. A prompt tells you to use the auxiliary lead. The cylinder firing order is displayed at the top of the screen as ignition. At the bottom, the power stroke is identified as cylinder. The cylinder's power pulse should occur as a rising waveform in the corresponding cylinder zone. Cylinder zones are not identified when an engine has more than 10 cylinders because the zones become too compressed to be of much value. If you have any questions or want more information about anything on the screen, press Help. The background grid and cursors can be helpful visual aids when you want to compare waveform characteristics. The grid displays time as degrees of crankshaft rotation. Amplitude is divided into even increments that will help you compare the relative height of waveform peaks. Use the cursors when you want to evaluate portions of the waveform. The distance between the active and fixed cursor is displayed at the top as delta degrees or delta relative distance. Use Waveform Size Select to compress or expand the waveform. The up arrow key will increase the waveform's amplitude. The down arrow key will decrease it. Vertical position lets you move the waveform up or down on the screen with the up or down arrow keys. You can manually select and short cylinders to see how a non-firing cylinder will affect the waveform. To short a cylinder, press and hold the corresponding numeric key. Cylinders will be shorted for the length of time the key is held down. If the vehicle has more than 10 cylinders, use Select Cylinder to select the cylinders beyond 10 and use Short Cylinder to short them. A power balance waveform can be stored in memory, or you can print the waveform for future reference or comparison. The power balance probe monitors fluctuations in engine speed by relaying changes in the speed of a crankshaft drive belt. The probe features a wheel which is applied to a moving crankshaft belt during the test, a handle, and a red freeze button at the end of the probe, which is pressed when you want to capture a waveform for viewing. The probe is attached to the auxiliary lead connector. The white lead is attached to the battery's positive terminal. The black lead, or ground, attaches to the battery's negative terminal. The yellow lead goes to the negative side of the coil. The red inductive lead goes over the number 1 spark plug wire. On an HEI system, the black capacitive pickup goes over the coil. On a remote coil system, the pickup clamps around the secondary coil wire. A DI assembly is required if you're testing a vehicle with DI. The capacitive pickup is removed and the harness connector is attached to the DI block. To perform a power balance test on a diesel engine, you must obtain a synchronization signal that will identify the cylinders. The Snap-on MT254 Lumi inductive adapter with a luminosity probe will enable you to obtain a sync signal on diesel engines with glow plugs. The Snap-on MT257 diesel pulse adapter can be used on diesel engines with 1/4-inch or 6mm steel fuel injector lines. Proper use of the power balance probe is critical to your safety and to obtaining reliable test results. When there are 2 or more crankshaft drive pulleys, always test the one with the most direct, easy access. Do not allow the probe to come into contact with any other moving belts or parts. Be sure your clothing, hands, and other pieces of equipment are safely out of the reach of any moving engine parts. Always observe standard garage safety when conducting a diagnostic test. Complete instructions for using the power balance probe can be found in the Counselor 2 User's Manual. You'll get the best test pattern when the engine is operating at a steady speed, from idle to about 1200 RPM. Faster engine speeds will produce more dynamic results that may mask problems. The waveform will look like a straight line, with fewer details to analyze. Ignition timing should be correct. Fans that cycle on and off automatically should be disabled. Position the probe wheel on a taut crankshaft drive belt, where the belt direction is moving away from the probe. You may need to use 2 hands, or to prop the handle against a stationary object to hold the probe in place, because the probe will have a tendency to walk off the belt. Keep your eyes on the probe and the belt. After a few seconds, press the red freeze button on the back of the handle and remove the probe. You're now ready to analyze the waveform. If you want to view the dynamic characteristics of a live waveform, have another person operate the probe. Do not attempt to apply the probe wheel and analyze the screen at the same time. If the cylinders at the edges of the screen are difficult to analyze, try turning the engine off and move the red inductive lead from the spark plug wire of the number 1 cylinder to its companion cylinder. Then, go back to the Snap-on screen and change the firing order so the companion cylinder begins the sequence. Now, go back to the power balance waveform, start the engine, and do the power balance test again. It's normal for engine RPM to vary a little at idle speed. This is known as hunting. It will cause a live waveform to drift up or down on the screen, and a frozen waveform to have an upward or downward slope. Extreme surges indicate engine problems. Use the Counselor 2 freeze button to freeze the test pattern. You may want to test cylinder power balance at different temperature levels, since temperature can be an important variable affecting engine behavior. Before we look at the characteristics of the power balance waveform, let's review the events occurring inside each cylinder when the engine is running. An engine is basically an air pump that draws air and fuel into the cylinder, compresses the mixture, ignites it to develop mechanical power, and then exhausts remaining gases. The up and down motion of the piston is released as mechanical power to the crankshaft only during the cylinder's power stroke. The crankshaft converts the cylinder power to rotary power. The four-stroke engine cycle occurs over 2 full revolutions of the crankshaft, or 720 degrees of crankshaft rotation. Each stroke requires 180 degrees of rotation. There are 540 degrees of rotation between power strokes. The cylinder power balance waveform displays increases in crankshaft drive belt speed as a rising slope that occurs after each cylinder fires and applies its mechanical power during the power stroke. Belt speed peaks as the piston nears the bottom of its power stroke and starts to decrease as the piston moves into its exhaust stroke. The decrease continues until the next cylinder fires. The number of peaks you see should equal the number of cylinders in the engine you're testing. The important portion of the waveform for a specific cylinder actually starts at the bottom of the wave after the cylinder fires. The cylinder zone numbers will help you identify individual cylinders. You'll see more detail on power balance waveform for a 4-cylinder engine than one for an 8-cylinder engine, because the time interval between 8-cylinder firings is shorter, and the individual portions of the waveform overlap more. The shape of the power balance waveform will depend on the type of engine you're testing. This is normal. Compare the individual cylinder portions of the waveform to each other. Each should have similar rising and descending slopes, and the top and bottom of the waves should be relatively equal. Because this is a dynamic test, minor variations will be seen in the test patterns. These are normal. Look for cylinders that have no peak, or the descending slope is steeper or longer than the others. Keep in mind that a cylinder that is not contributing its share of power may affect the performance of good cylinders that fire immediately afterward, or of a good companion cylinder. A cylinder that is not contributing its share of power will have a flat pattern. Since the next cylinder fires when the crankshaft belt speed is slower than normal, the speed rises more than normal, and another cylinder fires before the speed begins to decrease. It takes several cylinder firings before the waveform begins to look normal again. When the engine is running rough and a problem is showing up randomly in different cylinders, a problem, such as a vacuum leak, is affecting all of the cylinders. A problem in one or several cylinders suggests a mechanical problem. Check the mechanical integrity of the engine. If a problem shows up in all of the cylinders, the problem is probably outside the cylinders. Check the integrity of the primary and secondary ignition systems. The Snap-on Counselor 2 Power Balance Probe provides diagnostic information that can be used to alter the performance of the vehicle you're testing. Be sure you understand the meaning of the information you're obtaining with the probe, and that the information is correct before using it to service a vehicle. If test data should appear to be incorrect, check the troubleshooting section of the Counselor 2 User's Manual, or contact your Snap-on representative for assistance. The Snap-on Counselor 2 Power Balance Probe gives you the advanced diagnostic testing capability you need to identify elusive engine problems in today's sophisticated vehicles.